Hello, it is August 2017, and this is episode 76 of the Unseen Podcast. It's August 11th to be precise, and so this is our summer hiatus non-episode. The summer hiatus is not ended yet. It will end at the end of this episode, not at the beginning. So with us tonight are, from left to right on my screen, Sam Lichtenstein.
Hello from New York.
Patrick Festa was here, but he's disappeared. Say hello, Patrick.
I'm here.
Okay.
Hello, Patrick.
Yeah. And Nick Nielsen.
Hello, Paul.
And Mike Bohler.
Hello, Paul.
And it's not impossible other people will join us later, and we'll just have to roll with that when it happens. Okay, talk amongst yourselves. What's going on, guys?
Well, here, I have a random question for Mike. So, Mike, it's my impression that you're a member of the Skeptic community. Is that correct? I subscribe to your podcast, which is a Skeptic podcast. So.
Yeah, I guess technically, yeah.
So I don't know how you feel about the JFK assassination, but one thing that crossed my radar is that recently some JFK documents were released, and I was curious whether you had anything interesting to share about the latest release, and to know that those of us who are not so tuned into the skeptic world might not know about.
Well, the documents that were released are mostly the CIA's. I'm trying to make a kind of an assessment of it, but it sounds an awful lot like the documents are going to expose what they didn't want to tell, or what they didn't want to go public at that time, and
which is like 1990, around the time of the Oliver Stone movie. Is that the issue?
It's before. Well, this is the documents are from the assassination. There were. They were requesting documentation on Oswald, and there was a bit of a screw up. And when Oswald went to Russia, any attention to it, and
meaning the Warren Commission didn't pay any attention to it.
Well, no, the CIA when Americans go over and defect. A report will be written on that person. The CIA will collect, the FBI, all these State Department will collect documents, and apparently, the CIA never took any documentation, and they didn't want them to know that this was somebody they missed, and it could have been though there's no real evidence the Russians or the Cubans were. There's really hasn't been any real good connections, but Oswald did try to. He went to Russia. He tried to go to Cuba, and kind of a lot of that got. But it was like the CIA should have been monitoring, and they didn't, and that would have raised some questions about. Why are they chasing this but not this guy? And
so sort of like embarrassing bureaucratic oversights, but nothing like too smoking.
Nothing incriminating of
the only
CIA.
Interesting thing I saw referenced, and I haven't checked the documents myself, is that the mayor of Dallas at the time was apparently in the database as a CIA asset, and that was not previously known. Not necessarily a useful or important piece of information, but sort of vaguely interesting. Who knows? Yeah. Anyways. This is this is not totally germane to the Unseen podcast, but since Mike was here, I figured I would ask.
No, it's a non-episode. You can ask whatever you want.
Yeah. Well, see, a lot of these assets, like the mayor, he, if anyone at the time, anyone traveling outside the country, and whoever, they would get a call when they come back to the country, and they would be debriefed by the CIA just to get their opinions. It wasn't like they were investigating. They were just trying to collect information about, what their dealings like. Clay Shaw made trips to Cuba to as part of his trade company. So he would be asked, what was it like dealing with the officials and how things were working over there. It wasn't, do you know Oswald? Do you know this? Do you know that type of stuff? It was mostly more background information, and that's the type of stuff the CIA was supposed to be doing.
A lot of stuff that might be handled by the State Department these days, but like in those days, it was more. Everything was higher octane because of the Cold War.
Yeah, well, everything was supposed to be collected, and like I said, this is mostly the CIA dropping the ball on certain things, and nothing that really changes the. I don't see anything that really changes Oswald, though it might, amongst the conspiracy types, might raise questions about, was Oswald a CIA asset to assassinate Kennedy?
Of course, those types have always assumed that. So, that's nothing there.
It's just, But I think there's still some more documents that are supposed to get released. I think there's one more batch that's supposed to come out later. I forget the
October something. There's a deadline sometime in October, I believe.
Yeah, I think that'll be the last batch.
Statutory.
Yeah.
Who is sitting on these documents?
It's all their files, stuff that they keep in the archives, and I think maybe it is in the National Archives right now. It's just you can't get to them until they get. They got to be reviewed and names redacted if people are still living and stuff like that.
Just as a ballpark figure, how many people would you guess had access to them at the CIA? We talk about a half dozen or 60 or 600, 6,000.
I think anybody who would have clearance to look at them would be able to get to them.
So, but if your heuristic is that the more, it's impossible to keep a conspiracy secret, somehow proportional to the size of the pool of people who have access to the information, the caveat I would raise is the question that the consequences for releasing the information are quite severe legally. And so, like recently there was the Reality Winner case, this woman whose name is kind of hard to believe, Reality Winner. Like, she's some low-level grunt at the NSA contractor and gets the book thrown at her for printing out some documents and sending them to Glenn Greenwald or whoever, Yeah.
Well, it's easy to hold low-level people to account. It's much harder to hold high-level people to account. It's just like in international finance, small countries get their feet held to the fire where big countries are viewed as too big to fail and they get all kinds of special treatment.
Yeah, it's a fair analogy, I would say.
If you're Edward Snowden, you have to run for your life. But if you're somebody who really matters, then it's not so bad.
Yeah, well, you have the Foster or the Dulles brothers at work suppressing a lot of that information. Yeah, I think it's kind of tough, but like I said, much of this, the Warren Commission got it right. But they were missing bits and pieces. These are the bits and pieces that they were missing, and it really doesn't change the outcome, the conclusion of the Warren Commission. Most of the stuff is like, it's like background of background information. So, at least as far as these documents, the ones you're referring to, these aren't going to change anything. And a lot of because I did a show on the JFK assassination.
Right. I don't remember if I listened to that one. It's probably a while back, though.
Yeah, I think it may have fallen off my RSS feed, but there was. When you go through just recently, Jim Mars was the main. I want to say he assisted Oliver Stone for his his JFK movie. But that movie is Jim Marrs and his quote unquote research. He was trying to pin the Clay Shaw, the Jim Garrison investigation, and but Marrs,
He had methodological issues.
well, there's that. Well, it's a typical conspiracy. You have your, you want to prove that if you want to prove the conspiracy, then you cherry pick what you want to make a chain to say, and that's what he basically did. That Clay Shaw and had been this CIA asset. That was the start, and then had gotten Guy Ferry, CIA pilot, used to fly into Central America a lot. Was able somehow he's linked to Oswald through
Trips to Mexico City and all that, or
Louisiana, and because Oswald was in the Civil Air Patrol.
this is where it's been. I've researched like myself cannot even keep track of the stories with any degree of accuracy.
Yeah. Oh, yeah. Because there's the Cuba connection, the Russia connection. There's the Lyndon Johnson connection, the Mafia connection,
The George H.W. Bush connection.
I don't know if that's. I never saw. I haven't heard that one.
Well, that's a more recent one. That was that George H.W. Bush is famously one of the only people who can't remember where he was on the day of the assassination. And Tim Weiner, the CIA historian, journalist guy, has placed him in Dallas that day.
That's a good question. Somebody remind me of the exact day and year.
What is it? It's
October 63.
November 22nd, 1963.
Okay.
1963.
Yeah.
I was 4 years old. I remember being sad that day.
Yeah, you have memories from 4 years old? That's impressive.
It's just it's a vague. I remember because obviously it's so political,
Yes.
Remembered that it was embedded into my head. But as far as personal memory concerned, I remember. I don't know if I was, with family members that were watching the TV or something, or hearing it.
But you would have been a little bit older.
I was starting to cry.
By the time with the Martin Luther King and Robert F. Kennedy assassinations, you would have been a little bit older, so you probably have actual memories of those.
Yeah, but no, I got some, vague memories of being really sad, maybe even crying a little bit. I was 4 years old.
I was 17 months old, and all I can remember from that was my mother had it on the TV and the procession.
Yeah, that's what I mean.
Washington.
It was obviously televised and everything. Being 4 years old, I have some cognitive capabilities,
Of course, I was more mad that I couldn't watch my cartoons.
Right. So the more recent analog of all of this is the DNC hack and the Russiagate. And so I'll flag for your guys' attention if you want to go down a rabbit hole. The URL is g-2.space. And that's a researcher, a pseudonymous researcher in the United Kingdom who's been researching the Guccifer, what's his name? Guccifer? The guy who supposedly hacked the Democratic National Committee in July of 2016. And he's been investigating the forensic evidence of this hack. And he has various interesting conclusions. So there's my advertisement for a rabbit hole that you can go down to when and if you feel a desire to go down a rabbit hole. But
G2?
G-2
Yeah, it says Guccifer 2.0 game over.
Paul, real quick, isn't David Grigg supposed to be joining us?
No, he bailed to the last minute.
Oh,
Sorry. You can leave now.
Anyways, I'm done with all my conspiracy theory questions, so we can move on to other topics. But
Oh, thank you.
I was kind of hoping David Grigg would be here. I wanted to ask him if I could publicly read a portion of his stories.
You can still do that, Patrick. You don't need the podcast for that.
you just have to accept the legal liability that if you're violating his copyright.
I figured that's what I was going to ask him. I was going to ask him.
I give you his email address. You can send it.
Did you? Where?
Yeah. Well,
it's a forgiveness versus permission sort of situation. So you have to accept the risk that he might sue you for copyright infringement.
yeah. I think you should.
Well, it's sort of what I'm trying to do. Although my first attempt was pretty lousy. I'm trying to have this little thing in my. I was trying to, come up with some YouTube content, and one of the things was about reading and writing and different authors and stuff. And I had featured David Grigg, the book that I actually bought of his, and I was going to make an attempt at possibly reading a paragraph or so out of one of his stories, and I was going to ask him permission if I could actually do that.
I think you could read a paragraph without asking permission.
I think that's fair use, man.
Yeah, that'd be fair use. Now, like a whole chapter might be borderline, because he might want to sell the audiobook at some point, right? At least in principle.
But if you do a good job, Patrick, he might hire you to record the audiobook.
If you saw my first attempt at Cordwainer Smith, you would laugh at me because I had trouble seeing it. I was reading it like, so I got some new lighting. You should see the light I got now. I could turn on the light and it'd be like the sun shining in here.
No, but now I want to hear it. So read the paragraph because I haven't read his book. So
I haven't. I was going to ask him to do it, and I got the book around here somewhere.
Well, do it. Go ahead. Keep it to less than a chapter so we don't get sued by the notorious David Grigg.
I have to find the book now.
Copyright troll if there ever was one.
You guys put me on the spot now.
No, I don't think David's a copyright troll.
There we go. No, I think he's a really nice guy. I think
or
really
a patent troll or any other kind of troll.
So what's the book? Which book is this? The Riddling.
Oh, I have that. Yeah.
Yeah, it's. I
have it on Kindle though.
It was plugged on your Unseen podcast, and I went out and bought it. And I got this. How many stories? I never actually finished reading the rest of the stories.
So it's a novel or a short story collection?
The collection of his short stories.
Okay.
The Riddling being the first one, and it's a very interesting sci-fi. But I'm not going to try it now. I can't. I just wanted to show you the book. But yeah, so I was trying to come up with some content.
Now you've disappointed us all.
Oh, you really want to hear something? I don't know.
Just
I
a
got to turn on all the
paragraph.
lights. My eyes are shitty.
I read all 7 Harry Potter books to my children out loud.
You can recite some original Patrick Festa poetry if you'd prefer. That's an acceptable substitute.
Patrick,
I had to bring the sunshine out.
looks pretty bright in there. Yeah.
Yeah, I mean, I just got the light, and I didn't try it out on reading yet. See, now I got to change my reading glasses. You guys are putting me on the spot, man.
But
Yes,
you
we
can
are.
also just explain why you find the story interesting, what it's about. I'd be curious to hear.
Well, there's several stories in here, and my favorite one so far, I didn't even finish reading all the stories, but my favorite one, well, the Riddling was good. Let me see. I really liked, where is it? What's the name of that damn story? The Book That He Stole. I really like that one. It's been a while since I read it, so I'm going to have to read it over again. The Book That He Stole. Who would have thought of all the things in the world Willie Taylor could steal, that he would steal a book? And that's all I'm going to read you guys, because I got to save that for the...
It's a good teaser, I have to admit. Like I would keep reading from that point, you know.
Okay, we're going to turn off the sunshine. I didn't want to do it here. I wanted to get paid for it from YouTube.
Paid for it. Now, if you get paid for it,
Well,
then
I got
David
one
gets a
price
cut.
That's what I'm saying. See, that's why that's why I didn't want to.
But what are the science fiction-y themes of the story?
I'd have to read the whole thing over again. It was like last year when I read it.
That's fine if you don't want to get into it. No problem.
I was hoping to ask his permission. I didn't want to. If I could do it, then the Golden City was good too.
Well, I found that a lot of authors and a lot of musicians are happy to have their work played on podcasts or read on podcasts because they kind of given up the notion they're going to make a fortune out of it.
Well, I mean, being as I met him personally, and being as you can see in any, you gave the example of Harry Potter books, for example, in the beginning says, no part of this can be copied electronically, et cetera, and so forth and so on, or we come out and hunt you down and slit your throat kind of thing. I was like, okay, I better get permission. Seeing as how I met David Grigg and I really liked the guy, and I didn't want to,
Well, no, they I'm sure he would be fine with it, but you'll have to ask him. That is the right thing to do, is ask him.
Yeah, that's what I figured.
Yeah, and unfortunately he's not here tonight, but I mean, we'll give me some links and we'll put them in the show notes. People can check it out for themselves.
I believe the fair use standard is 60 words.
60 words?
Yeah, I think with music it's 30 seconds.
60 words?
Yes, that's what I understand it to be, but I'm not a lawyer,
roughly a tweet.
I read a lot more than 60 words on the Coordinator Smith, although I didn't do such a great job because I really couldn't see it well. But Coordinator Smith is died in 50 something, 60. I mean,
And you don't think he has any greedy grandchildren?
I often have misgivings about the long paragraphs that I quote on my blog. So I was interested, a couple of months ago, I wrote a piece in which I quoted a pretty long, but not really long, not a page worth, out of Eric H. Klein's book, 1177 BC, the year civilization collapsed, or something like that. And he actually, I don't know how he found it, but he actually made a comment on my blog, and he didn't complain about my paragraph long quote, which was more than 60 words, but much less than a page.
Okay.
So Nick, to change the subject, Nick, are you at the Starship Congress, or were you?
I've just returned.
So let's hear a status report. I think that'd be interesting to the audience.
The most recent Icarus Interstellar Starship Congress was held in Monterey, California, at the Hyatt there. That also has a big golf course. Apparently, it's a big golfing destination. I didn't know that until now. August 7th, 8th, and 9th. So I was there for the entire day of the 7th, the entire day of the 8th, and for the morning session on the 9th. But there were still several speakers that I missed on the rest of the night. So I'm sorry I didn't stay out the rest of that day, but there were no later flights. I actually tried to change my flight, but that wasn't possible. So the conference had two themes. So one of the themes was the moon in Interstellar, and another of the themes was spaces for everybody. So and when they first started talking about having these two themes for the conference, they made it sound like they were going to lay it out pretty clearly. So one day would be all about the moon, and another day would all be about spaces for everybody. But it was more like there was a lot of rearranging of the program as we went. So things got mixed around. So David Brin, the science fiction writer, was there. He gave the opening keynote. And
was it about the moon or about space for everybody?
It wasn't. Didn't focus on either of those. He pretty much he did talk about what he called garish moon bases, because I love those old 50s and 60s space illustrations, and I use many of them in my own presentation. But he characterized them as garish. So he did briefly mention. He did briefly mention moon bases, but it wasn't really a focus, nor was spaces for everybody a focus of his presentation. My takeaway from his presentation of what I his response to the Fermi paradox, which I would call the water world hypothesis, is that most habitable worlds are water worlds. So the intelligent inhabitants don't develop hands and they don't develop fire. So we're one of the rare habitable worlds. We could actually build a technology, and that's why there aren't other technological civilizations out there. So that was my takeaway. And then in the question and answer session, he started talking about what he considered to be the growing anti-science ideology of our times, and he got a good response when he said, "I see a whole room of burnable people here," meaning that if the public really turned against science, we would be the first committed to the flames of a new auto-da-fe on the part of an intolerantly anti-science regime.
So not to interrupt the rest of the report, because I'd like to hear more about the other speakers, but do you buy that Waterworld hypothesis?
Well, it's a fun idea. I don't think it's a definitive answer, but I don't think the Fermi problem has a definitive theory. A definitive response. I think that there's so many things that would feed into any ultimate answer that might explain some of it, but it doesn't explain all of it. Does that make sense?
I'm just saying, like, given what a terrible movie Waterworld was, like, you know, should we give any weight to David Brenn's opinion on this subject? You know?
Yeah. Well, I don't give a whole lot of weight to David Brenn's opinion because he talks smack about me on Centauri Dreams after I wrote a piece on SETI and NETI that was posted on Paul Gilster's Centauri Dreams, and he brought one back that wasn't very nice about me. So I don't have a very high opinion of the man, but be that as it may, he was a pretty good speaker.
Yeah, we can set aside personal animosities. That's the conference report.
Not a very nice man.
Yeah, I guess I do my own trash talking. So then we had Mike Mongo, who was one of the organizers and leaders of the conference. He spoke, and he was pretty much focused on the spaces for everyone a theme, but I didn't take many notes about that. Then there was Jess Shanahan, who is a linguist and an astrophysicist, and she focused on the spaces for everyone thesis, and she particularly talked about disability access and what she called the social model of disability. And she introduced a theme that many of the people in the conference took up when those who talked about spaces for everyone, talking about space as a blank slate where we can hopefully start over and create something new that avoids mistakes of the past. That was a theme that came up several times, which I made point because it's such an interesting way to approach space. Then the big name, to me, the most important part of the conference, Miguel Alcubierre himself was at the conference. The man who wrote the paper that proposed the possibility of a workaround for faster than light travel that doesn't violate general relativity. Apparently he knows Mike Mongo, is in correspondence with him, and Mike asked him if he might consider coming, so he did, and he gave a presentation that was very clear, very accessible, even to people who don't know mathematical physics. And one of my takeaways from that is when he just was talking about how he came up with the idea, he said that you can approach astrophysics by way of looking at the mass energy distribution in the universe, and then from that derive what kind of geometry it has. But you can also look at the question from the opposite end, and you can say, well, what kind of geometry do I want? And then you determine from that what kind of mass energy distribution you need to obtain that geometry. So if the geometry you want is a space-time bubble in which space is compacted in front of you and expanded behind you, so you stay more or less still inside your space-time bubble, but you were able to travel to another star extremely rapidly. That's a particular geometry, and you can calculate the mass and energy needs that you have to have in order to realize that geometry. So my my apologies to Miguel Alcubierre if I've gotten that incorrect, but that was my takeaway from his talk, which I enjoyed a great deal. And also a clarification about a simultaneity. We all know that general relativity implies the relativity of simultaneity, but he added the, I think, important qualification that there's always agreement on simultaneity within all events in a given light cone. And so since none of us step outside our own light cone, none of us ever see the relativity of simultaneity. So I think that's an important thing that a non-physicist like myself is helped by hearing that sort of thing.
I find that a bit confusing, but okay. I'll have to follow up later.
Okay. Well, what part of do you find confusing?
Well, I mean, the relativity of simultaneity, there's some pretty simple experiments that can confirm that.
Yes, they're pretty, but they tend to be posed. Einstein posed his examples with trains and moving trains, and it makes it sound like within your own light cone you could actually demonstrate this. But we can show a space-time structure, and just there are multiple light cones, based on where you're at in the universe, where you're at in space-time. And well, according to him, and once again, if I got this right, I could have taken notes incorrectly. That the simultaneity and order, space-time order, is always going to agree within any one given light cone.
Oh, order maybe of events. Yeah, I can see that.
Right.
Also,
you might.
It just seems quite. There's a lot of potential for intuitions to break down in exotic geometric solutions of. So there's these Einstein equations, right, that govern what geometries can arise. And if there's sufficiently exotic, then our intuitions about how causality works could break down in certain ways that might be quite.
Well, relativity doesn't say causality is wrong. It just simply says that two events two events that appear simultaneously in one frame may not appear simultaneously in a frame moving with respect to that.
No, I would say this. Like, I think our intuitions about relativity, to the extent we have them, are grounded in a Lorentz, flat space-time.
Yeah.
Our four-dimensional space with a metric of signature 3-1. It's one time dimension.
One temporal dimension and three spatial dimensions.
That's right. And
but general relativity has the same metric. But it's just...
Right, but the point is, when you account for the curvature of space-time, then these intuitions can potentially break down in quite strange ways, and it's.
I gotta take a break.
I don't have any confidence in my own intuitions about how, for example, in highly curved areas of space-time near black holes, etc., whether our notions of causality are reliable, intuitive guidelines to how the physics should work out.
Well, you'd have to do the calculation, but I think you still get. I'm not sure you can reverse a timeline relative to, at least outside the event horizon. Now, inside the event horizon, all bets are off. Actually, space and time switch roles inside the event horizon.
Brian Cox did a whole lecture on if it were possible, how to actually, go back in time, and you would have to be near a black hole. And he did and don't ask me to explain it. You'd have to see the lecture, and it has to do with actually.
No,
go ahead and explain it, Patrick.
I couldn't possibly, yeah.
A fun fact I learned today was that Kurt Gödel, a colleague of Einstein's at IAS in the 1950s, I believe.
They were both dead by 1960, but in the 40s, in the 30s and 40s, they both fled Nazi Germany.
Right. So Gödel, I think, quite famously, actually, was one of the first people to discover the solution of closed time-like curves for Einstein's equations, I believe.
Yeah,
effectively the possibility of time travel, and so I was
only in the universe with a certain rotating space-time structure.
Right. So I was vaguely aware of that. It's already pretty interesting because Gödel is a logician. It's not so obvious to me why his mathematical research would have led him into any particular interest in this direction. But what I learned today was that he was interested in ghosts, and he thought that, time reversal type solutions to Einstein's equations might lend insight into the phenomenology of ghosts in human experience.
He was a pretty strange guy.
He was also a personal friend of Einstein, so I'm sure.
They both lived in Princeton for about 20 years.
But I'm sure they talked about general relativity, and that Gödel's interest was sparked by that. There's a great book on this, by the way, by a guy by the name of Yorgrau. I can't remember the name of it, but I can find it.
Einstein was also quite religious, and Gödel, I think, famously had.
Well, no, Einstein wasn't really that religious. No, he wasn't.
Well, I think he was, if not a believing Jew, at least an interested Jew. Well, but
I don't think. I think his concept of God was basically the universe.
I think he told.
I think that's probably right.
I think he told a few jokes about it, and people didn't realize.
But Gödel, I think, took the notion of God more seriously. At least that's my. Probably Nick knows better than me, but he has one of his famous contributions to philosophy was the supposed logical proof for the existence of God.
Yes. There's been a lot written on that, on ontology, and there's apparently a lot more in Gödel's notes about it. That's his notebooks are only now starting to be transcribed, and so it'll probably be another 20 years or so before they're fully transcribed and translated. But there has been a paper that's
it's hard to know what to think about all of this, but I have no idea what Einstein thought about religion, really.
Well, that's actually pretty well documented.
Well, there's an entire book on that by I think it's Max Jammer wrote a book called Einstein's Religion or something very similar.
Yeah, I'm not an expert. Like, I've read roughly half of the what I think is the definitive biography of Einstein, Subtle is the Lord, which was written by a physicist.
Yeah, that's an excellent book.
Yeah, it's an excellent book, and it touches upon this in some areas. But I don't have the knowledge at hand in order to comment definitively on it. But definitely worth reading, I would say, for anybody who's interested in physics, because the fact that the biographer had the relevant scientific expertise makes a real difference in terms of the depth of analysis, I would say. But
the book to read on Einstein and religion is Max Jammer's book called Einstein and Religion.
Okay, I'll look into that.
Yeah, not to back up on the subject, but getting back into faster than light travel, there is actually a phenomenon that for some short period of time, some astronomers and scientists thought they were seeing faster than light movement. There was a supernova somewhere I think it was in the constellation Monoceros.
You mean talking about the neutrinos?
No, the actual visible light. What happened was they saw the supernova in Monoceros or something. There was a star that got bright all of a sudden by thousands of times, and they were watching this supposed, expansion of this cloud that apparently was moving much faster than light. What's the actual word for faster than light? Superluminal speeds. So what they finally figured out was that this cloud of debris or gas or whatever was there all the time, and when the star lit up, it lit up this this gaseous stuff that was already there, and we were seeing the light coming out of it as it's akin to taking a laser beam powerful enough to shine at the moon, and just by flicking your wrist, you can literally make the dot on the moon move faster than light. So there's no physical thing that's actually moving faster than light. It's the angular. It's akin to that, because the light, the gas was already there, the dust was already there, and it was being lit up. And as it's lighting up and being refracted, and what we're seeing, it looks like the gas was expanding faster than light, but in fact the gas and dust was already there. It was just being lit up that way, and we were observing the phenomenon as an optical illusion that it was actually moving faster than light.
Well, yeah, I remember when I was a little kid, like 5th grade, I was trying to disprove Einstein, and that was one of the first things I thought of. Is I could take my flashlight and whip it around really fast, and that spot of light can move, in principle, can move faster than the speed of light. which is true. It can, but there's
Right.
nothing. There's nothing
does.
being.
But it's not a physical thing.
There's
Now, if
nothing.
you-
There's nothing moving fast. It's just what I see illuminated as I look.
you know, if you reverse that and you look up at the stars and you twitch your eyes from left to right, your vision is moving thousands of light years in a split second, you know, or less. So,
Yeah.
you know, it's,
Yeah, but no actual detection.
right. Now, if you were to replace that with a rod of some kind, even if it was super light, and you were to try and move that rod, it would be impossible
That's true.
because you're trying to accelerate that matter, and you would need an infinite amount of strength, an infinite amount of energy, strength, whichever you want to call it, in order to get that thing to accelerate past that point, you know, to that speed.
That's actually quite interesting. So you're saying you can actually say something about the sort of positive versus zero mass of the photon is relevant to the kind of fundamental physics of
Well, it's not a solid object. Even if it was a bunch of particles, the particles are separate from
No
each other.
photon. No photon moving faster than the speed of light. It's different photons.
Right, it's different photons, and it's that perception of the dot in your brain you're thinking that dot is a single object, and it's not. it's this reflected thing. So
Yeah, we say that actually all over the universe. The jets that come out of galaxies illuminate gas around the galaxy, and the jets shift. And as they shift, you can see a superluminal movement in what part of the gas is being illuminated by the jet. It's just because these jets are many, many light years in size, and the gas is is galaxy scale. So you see that.
Well, also the large scale structure of our universe, when the universe at the farthest edge of the visible universe are redshifted just to the point where we can barely see them, they clock in at just under the speed of light, but everything that goes over the speed of light is so far from us.
Well,
the distance
yeah, but that's not
expansion.
things moving faster than speed of light. That's space itself moving faster than speed of light.
Space itself, but it seems that you're getting close to measuring something.
Yeah.
There is some galaxies, one or two that they know of that are shooting out jets of stuff at relativistic speeds, but that's meaning under the speed of light, but really freaking fast.
You guys are throwing these statements out, but I'm like, at least from my read of the physics literature, people are very uncertain about whether any of this is true. Like the expansion of the universe is pretty mysterious on a fundamental level. So much less the rate at which the universe is expanding. The cosmological constant.
Well,
question.
but there's nothing in relativity that says that space can't expand faster than the speed of light. It just says
that's true, but it's still weird that it does.
And it's weirder still that it's accelerating.
Yeah, I read that in the Journal of Weird Stuff.
The scale of the cosmological constant or whatever. These are more surprising than I think most people reading the popular scientific press necessarily appreciate. Maybe I'm wrong. Maybe physicists are overblowing.
It's definitely hard to wrap your head around.
Inflation, for which there's a lot of evidence that inflation is right, but inflation requires that space-time expand much faster than the speed of light over a very short period of time. But again, there's nothing.
But this fact of the when was this discovered? The late 1990s.
1999 is when the accelerating expansion was.
Well,
right.
I think
this is a relatively
inflation was
recent
proposed in the
discovery,
80s.
is my point. And so, the fact that we treat it as more than a provisional discovery, given that we have so little understanding of how physics work on the relevant timescales, is interesting to me.
Well, it is controversial. It's not taken as dogma, but there are a lot of really
there's solid evidence in favor of it. I agree.
Yeah, well, there's a lot of things that are hard to explain without it. Let's put it that way. And now maybe somebody will come up with something in the future that can be explained, that can explain everything we know without inflation, but nobody's come up with anything yet. It's the most, but the problem is inflation requires this mystery field that,
or more generally, any consistent theory I know of, like there's some role for dark energy in any consistent theory of cosmology, as far as I can tell.
It's campaign for the return of the ether.
Well, actually, I don't know. I think that dark energy, you don't really need dark energy for the basic cosmology.
For keeping everything consistent with observations the
observation, we have observations that drive us to dark energy, but we don't need dark energy to get through the first second of the universe's existence. It's later when we see this accelerating expansion that nobody knows how to explain except some kind of force.
Which is more surprising, the first 3 seconds or the next 10 trillion years? I mean,
it's all surprising.
Well, it was Einstein who thought it was his biggest blunder at the time when he came up with the cosmological constant in order to make the universe static. He couldn't. That was the joke about the religion joke. He didn't believe in a God who could throw dice or the God who threw dice.
That wasn't the cosmological constant. That was quantum mechanics. But
okay. Well, anyway,
whatever. Same guy.
But the cosmological constant.
No, it's a totally different God, by the way.
Now, what he threw away and what was thrown away for decades is now what dark energy actually is.
We don't know that for sure, although dark energy is consistent with the cosmological.
That's what I'm saying. In other words, it's the same idea brought back.
But I think the point I was trying to make is that, ontologically, it's on a very different level from like the existence of the planet Neptune, which we also need to explain observations consistent with our astronomical experience. Dark energy is out there in a way that Neptune is not.
Well, yeah, I mean, we have all the physics we need to explain Neptune. We don't have all the physics we need to explain dark energy.
Well, dark energy is just a cipher. I mean, when you say dark energy, it makes it sound like critics of Descartes would have called an occult. Well, critics of Newton called an occult quality. Like when gravitation was introduced, it was just this is gravitation that is right. Universal.
It's like introducing an unexplained phenomenon as a theoretical construct within your physical system.
Exactly, it becomes a variable.
But it has a long history of working well, by the way.
It has a long history of working well. But you run into this with 5 parameters I can fit an elephant, and with 6 parameters you can make him wiggle his nose, or whatever the famous Dyson or Feynman or whoever it was, one of those physicist guys said it. It's you run into the issue of being potentially able to explain too much, and it's intellectually a difficult situation to be in.
Well, true. That's something that people are acutely aware of.
No debate for me on that point.
I mean, in physics we have 24 constants that are only empirically determined.
I believe it's 18 in the standard model, but there's probably some beyond the standard model.
It's more than 20, I think, when you add them all up. And it has they're mostly coefficients of how one particle interacts with another, one field interacts with a particle. And those are entirely empirically determined. We don't know where they come from. A lot of people find that unsatisfying. Others are saying, well, that's just how it is.
And I originally would have intuitively felt like I was in the, okay, that's just how it is camp. But the more I've tried to learn a little bit about quantum field theory, the more I'm like, that's completely unsatisfying.
Which particle physicist said if you think you understand quantum physics, then you don't understand.
Feynman and several others said that.
I think it was Hans Bethe, maybe, but although if you think you have an intuitive understanding, then you probably don't. You might have you may know how to do all the calculations, which takes 2 or 3 years of graduate school just to get to that point. But that's even if you can do the calculations, you get the right answer, you still don't know exactly why this model works. it's very difficult to make it. Nobody's found a way to make it intuitively obvious.
It's also not so mathematically obvious. Like, I've been spending the last few days trying to see whether certain ideas from gauge theory in physics might be relevant to like data science type applications, and just understanding what the statements that physicists make are in a sort of clean mathematical language is quite challenging, even though these things mathematicians have been poring over these things for decades and have created a lot of very valuable insights from them.
You know about the Dirac delta function, right? That's a classic example.
That's a very classic example.
Dirac wrote it down. Everybody in physics said, yeah, that makes sense. We'll use that. And then it took the mathematicians like 20 years to justify it. But nobody in physics ever had the slightest doubt that it would be fine.
Yeah.
But the mathematicians had to deal with all the
this is basically
pathological cases.
This is essentially why Witten got a Fields Medal in mathematics. Because he was able to leverage these physics intuitions effectively in math. But okay, so this is kind of out of left field, but I'm curious, given the circumstance of the summer hiatus episode, seems an appropriate venue. What's new in the world of anomalies? And the type of anomalies I have in mind are things like the M drive, I believe there's some sort of anomaly related to one of the, is it the Pioneer?
That's long been solved.
So maybe
the Pioneer anomaly, yeah.
Maybe the M drive is the outstanding major.
I don't think that's an anomaly. I think that's just a mistake.
You think it's just bullshit?
Yeah. Well, I don't know if it's bullshit. I don't know if I say it's bullshit, but I think it's very much an error.
I just haven't been paying that close attention, so I'm curious what any of you.
Well, I tried. I read Scheuer's original paper on that, and it's not a paper.
That was clear. That original paper is clearly bullshit. I think
it's wrong for several reasons. For one thing, he doesn't address the fact that he fails to conserve momentum, and if you were a real science paper that says, oh, by the way, all physics is wrong, has to acknowledge that and explain why. And
right. So presumably since then he's acknowledged that doesn't necessarily make up for the lack of the, I guess, self discreditation that comes from not acknowledging it in the first place. But I'm curious whether any of you have been following the blog threads on this line of research.
I know that Mike McCulloch has defended the M drive from the perspective of quantized inertia as a physical theory, and his theoretical explanation of how and why the M drive works is different from Scheuer's explanation. But that's about all I know on that.
That's about.
Well, the problem is Scheuer's explanation fails. So. At every level, and I think the experimental data they have so far is just not good enough to be persuasive.
I'm no scientist. I'm definitely no mathematician, and from what I can remember,
but you have an opinion anyway, right?
Right. From what I can remember, what the M drive was, I smelled the rat the minute I saw the stupid post about it, and it just didn't work. It just didn't work in my brain. It's just like, no, there's something wrong here. It's like somebody trying to prove perpetual motion or something.
It's not perpetual motion.
No, but I'm just giving.
But it's basically, it violates a comparably fundamental physical law.
Yeah. But if we go with,
it's like the people who talk about free energy, put this little freaking computer fan thing together, you get free energy. Yeah. Yeah. Where's the energy to spin the damn thing in the first place?
But
that kind of thing.
If you take the figures from the Eagle Works experiment that attempted to test the M drive, and it came up with a thrust that was so small it was perhaps within the margin of error of the experiment.
Right.
So a lot of people have questioned that result. However, even taking that minute little amount of thrust, I was interested to note in a post on Adam Crowell's blog, which is called Crowell Space. He has already made the calculations of how much energy you would need in order to run up a drive to become a 1G Starship drive. But it's not it's not necessarily an impossible figure.
Is it less than you need using, say, hypothetical fusion doesn't exist?
Fusion, but it's less than the original formulation of the Alcubierre drive. Now, the original formulation of the Alcubierre drive posited energy needs in excess of the known universe. So obviously that's not happening. Subsequent work by Sonny White has brought that down a lot, but of course it's still speculative at this point. But
well, not only that, but you have to create negative energy density, which
that's right. You have to create
incredibly difficult to do, even a little bit, and it needs a lot.
And then there's the horizon problem was explained to us at the conference.
So I have two directions I would be interested in taking this conversation. One is developments in sort of relatively plausible advanced propulsion technology, as mirror people, who I believe have made some progress recently. And the other direction is other anomalies that I don't know about. Like anomalies are where you look for new physics. And so we should be paying it, even if most of them are crackpots, we should be paying a special.
Well, here's one that's not crackpotty at all. And it's a total anomaly, and nobody knows what's going on. It's called Chabelsky star. And
that's a good one. Yes, I agree.
There are spectral lines that are, this is real science. This isn't crackpottery. Spectral lines in that star that indicate the presence of isotopes that are unstable and shouldn't be there. And
they're like 80, 90 atomic number type isotopes.
Yeah, higher than that even.
Yeah.
And it's a complete mystery as to why that star exists. And otherwise, it looks like a fairly ordinary star. And it.
So what I don't know about that is how much does that reflect our ignorance of high energy atomic physics?
I would I would, if you'd asked me that 30 years ago, I'd say probably a lot, but now I would say no, it doesn't. This is the atmosphere. This is the atmosphere of the star, not the core that we're seeing. The atmosphere.
But you say you think that like most relatively common fission-fusion reactions that happen under realistic circumstances, say with more than 0.00000001 probability, are not involving isotopes that we see in this star.
No, I mean, well, the problem is, a star. What's a star made of? It's mostly hydrogen, right? It's not, and the problem is these isotopes are very short-lived.
Right.
Yeah, and we should.
Right. So you're talking about like many higher order levels of atomic interactions that are required to produce exotic isotopes with atomic numbers in the on the order of 100.
The problem is people have been successfully modeling stellar physics for a very long time and pretty good at predicting what we're going to see in the star spectrum. And this is the only star we know of that has these features, and it's such an exotic thing that a lot of people have actually jumped to. Well, this might be a way of an advanced civilization signaling its presence, because it's just too weird. Now, is it possible that we just don't know there's an exotic physical process that is extremely rare that we don't know about that causes? Yes. I mean, you can't throw that out right away.
What about a nearby supernova explosion that happened not too long ago?
But we would know about that.
Well, I mean, not too long ago, meaning like thousands of years ago.
Well, we would know about that. There'd be a supernova remnant
that would have ejected this.
It would be close. It wouldn't be that far away.
So how come this is not the major target of study right now?
Well, there's not much more to say right now. We have the data. We don't have an explanation.
We have some data.
We have good. I don't know what other data you can collect. What else would you do?
Well, what do we have? We have visible. These are high energy signatures, right? So these are like it's mostly visible spectrum type.
It's not a source of high energy X rays or gamma rays or anything like that. It's
but it seems like a reasonable target for looking at radio.
Yeah,
I don't know.
I think that there's a lot of surveys that cover the star, and there's nothing odd about it. You have to understand that astronomers are constantly conducting surveys where they look out and cover a wide, pretty much the entire sky or most of the sky. There's the NOT, unbiased transient survey, known as NUTS.
I think I know what Sam is getting at, though. I have to agree with him. I mean, certainly you can't arrogantly say we have all the data. I'm sure there's data that we don't know, that we don't have, that still exists.
Okay, what is it?
We don't. How do I know that?
Well,
point is that we can't possibly.
Tell me what data we don't have.
No, I guess the point is like,
come on,
Paul. Let's assume SETI researchers are optimally rational, and so like they've all decided. Paul says this is the best star to look at, so we should get all the data from this star.
I'm sure they have. I'm pretty sure they have covered that star.
Right. So let's say then you come out with negative results. Are there not natural follow-up experiments from those negative, negative observations? Right.
But they have this star that's a long distance from the Earth. What are the odds that hundreds, thousands of years, I can't remember the distance, I think it's a few hundred light years away. What are the odds that at that time somebody was transmitting to Earth a signal that we could detect now with our SETI telescopes? Poor. Very poor. So, even if they wanted to, that's assuming they wanted to contact this planet, which at the time did not, from what they can see, did not have a technological civilization on it. They could see that it had oxygen in its atmosphere, or other trace gases that would indicate there was life there, but assuming they had advanced astronomy, but they wouldn't know that we were here. And why would they transmit to us continuously? There's no reason for that. So we'd have to be extremely lucky to detect a beacon, even if they wanted to send it. I
guess my next question is like, say you're like a physicist, a cosmologist, and so then you're used to like seeing some background radiation. Then you see this. How surprised are you? If you're 5 sigma surprised, why is this not a big deal for cosmology to try to like isolate?
Well, it's not a cosmological issue. It's just a star. There's lots of stars out there.
That's right. Okay. Maybe the scale is different, but like astrophysicist, a broader class of cosmologists.
They're surprised. They are very surprised. But what do? They already have the spectrum.
Well, so I guess the point is like, it's a 5 sigma anomaly. Are you looking at enough stars where you expect to see at least one 5 sigma anomaly?
Well, the only thing you can really do that makes sense is to look for more stars like it. And I believe the spectrometers are pretty much
we call that
maxed out right now.
We call that bucketing in my line of work. Like, you see something that looks unusual, you try to like restrict the class of situations which falls into roughly some class that's equivalent under, broadly similar in some circumstances, but you still have a lot of data. And do you still see a lot of the anomalous phenomenon or not? Right? That's sort of.
Yeah, but you have to remember also that astronomy funding is pathetic. And the U.S. actually has better astronomy funding than other places.
Yeah, but is astronomy funding unresponsive to the degree to which specific observations are surprising?
Yeah. There's a lot of things that are out there that we don't have a good explanation for. We usually there's some follow-up work, but the number of really sensitive telescopes that are available it's a handful. You can name them on 10 fingers, and hopefully that will grow as time goes on. But with if you have good spectral data already, how are you going to get better data? How are you going to get better? The thing is, surveys do not usually include detailed spectra. because
well, that's what I was saying before. There's the data. There is obviously more data needed. The kind of data may not be in our technological grasp right now.
well, it's really
Well, it might be within grasp if you're willing to expend the resources, but it's a question of whether you want to spend the money, right?
well. I mean, we can now do spectra for a lot of the brighter sources in a field of view of a big telescope. What they do is they put this. It's a very sophisticated thing. They put this mask over the telescope, and they have fiber optic cables running out of it, and it all goes down into this big room, and each fiber optic cable is plugged into a spectroscope, and they integrate for hours, and they can get spectra of many objects at one time that way. These instruments cost a lot of money, and they can only really work on big telescopes.
I think that if something is deemed to be sufficiently anomalous, in other words, strange enough, that resources are made available one way or another. So with the example, of course, of KIC 8462852, a Kickstarter campaign was held to raise money so that time could be bought on telescope.
But they could not get telescope time through the usual channels for that. Why? Well, because that's been explained on my other podcast, but telescope time is not allocated to high risk projects. You have to have a high chance of paying off. So
in other words, the whole structure is toward normal science and against revolutionary science.
Yes, yes, it is.
So if you're puzzle solving and it's a low risk activity, then you can get telescope time. But if you're trying to do something,
there are things like these dark matter searches that are going on, which are, but believe me, the people that get funding for that are heroes, and they have to do it. They're very difficult to pull off, and but there's I mean, unless you have broad community support that these observations should yield some clues about a big puzzle, and like dark matter or galaxy evolution, or how black holes got to be so big so fast, things like that. There are lots of other puzzles that are not solved, but the puzzle solving goes on, and the telescope time has to show this will give us a good chance of getting data to help us solve the puzzle. It's not if you say, well, I'm just going to sit there and watch this star for a long time, and maybe at some point it will do something weird. That doesn't get telescope time.
Yeah, but Paul, see that moves away from the original statement. Like I was sticking up for Sam because I was saying that you were like negative, like, well, what other data can we get? We got all the data. No, we can't possibly have all the. There's no such thing as all the data. There's data is ongoing.
What data would you propose we get from Cebulski star?
The point is that it's data that we don't understand yet, so we can't.
No, if we don't understand it, we can't make the observation.
Possibly answer that question. The point is that there's obviously something curious going on that we can't understand because of with the data that we have. So there must be something else that we need to find out or invent or come up with.
But I can't understand the question either. So the problem is, what observation would you make? Nobody knows.
The point is that implicit in your question is that there's certain spectra we're not looking at that we should be looking at, right?
Well,
that's what more data means.
So
the question is, like, it's all about cost benefit analysis, and I think it's kind of interesting from a SETI point of view, insofar as like we assume that the signals we're trying to observe, let's say they're being optimized to be detectable. If they're being optimized to be detectable, given X level of technology, that implies one thing for what we should try to do to detect them. But we're not optimizing to detect them.
No, we're not. Of course not.
We're not even close to optimizing to detect them. We're expending some like trivial fraction of resources.
Well, but if you cannot get a federal grant.
What usually happens is serendipity. like when I was a child, if I ever thought that I wish I could talk to a NASA systems engineer from the comfort of my own home, some guy named Paul Carr, that would be
he's an idiot. Don't talk to him.
An impossibility. But serendipitously, here I am at 58 years old talking to this NASA systems engineer because he invited me.
Here's the thing. Let's imagine you're like.
It wasn't that it was fun to do this.
I'm not an astronomer. I'm a system engineer. I make things work, but I don't make things. I don't figure out.
Let's imagine you're a civilization that's slightly more sophisticated than us, and you know about some bit of physics that we don't know, which causes and that this bit of physics implies a detectability peak at some particular frequency that we choose not to broadcast on because we don't know about it. There's some quirk of physics that causes us to not do some obvious optimization. And some intelligent civilization knows about this optimization. So they optimize given what they know. And we end up missing it because we're not optimizing to detect at what, from their perspective, is the obvious frequency to look at. If we're trying to optimize for,
then it becomes a filter, and you only pass that threshold if your civilization has passed a certain threshold of scientific sophistication, and anything less than that just doesn't measure up for communication. But on the other hand, we have to presuppose. I think we ought to presuppose a certain backward compatibility of civilizations. More civilizations with advanced technology or advanced scientific knowledge would know what kind of scientific knowledge is the low-hanging fruit and which would come first in the development of civilization. And that's where we focus on things like optical SETI and radio frequency SETI, because it's pretty obvious that a beginning technological civilization is going to develop radio and optical telescopes.
It's a fair point, but how well are we realizing that from our perspective as a relatively unadvanced civilization? Are we actually optimizing for the signals that we think a civilization of the 1790s would broadcast that, or the 1812s?
Well, we're way past that. But,
Right, but we're not like targeting our city at the particular frequencies that we think
it's
not very early stage radio broadcasting civilizations broadcast that, right? You have to sort of think about this issue. Like, what does the argument actually prove that any given level of civilization is going to be optimizing if they're trying to maximize their detection rate for a level of technological advance that is below their peak, but what they perceive as the probabilistic maximum of what is likely to be.
Yeah, you hit it right there. When they calculate that, they're probably going to figure that since they've been around for a very long time, which they have to be if we're all likely to see them, that we're much younger than they are, and they're going to try to sort of explain like we're 5, right? They're going
right. There's an implicit integral out to infinity.
It's like talking to a kindergartner, and so you talk on their level.
You're 6 years old. You're 8 years old, and you're talking to a kindergartner. You expect you're talking to a kindergartner, but your optimal utility maximizing action is to expect that you're talking to some person of an indeterminate age, between age kindergarten and age 1,000. So you have to do that integral to expect what the optimal point to observe at is.
Well, it's not just that, but it may be desirable to only communicate with the younger civilizations.
Well, you might not even have the technology to observe at the more advanced levels, right? Maybe the optimal point is somewhere like at energy levels that we can't even conceive of.
Right, but I mean, radio, for example, is any civilization that masters electromagnetism is going to very quickly move on to microwaves, and because it just sort of follows, and then the next thing you know, so radio should be something that any young technological civilization should have a handle on. So radio would be one thing. Also optical, which is why SETI efforts so far have focused on laser and SETI and the radio SETI, and because first of all, we're looking for signals that are deliberately sent to us because we don't have instruments that can detect anything better than that. And second, we're looking at signals that will pass through gas and dust and other things in the galaxy that are in the way, and that any civilization at any level of maturity should have mastery over. And so then you get, but if another thing, and Jill, I don't know if Jill Charter was the first one to bring this up, but she brought up that if a civilization wanted to advertise their presence and didn't know how to target it, they would create an astrophysical phenomenon that looked anomalous. And then in the normal course of astronomical work, people would stumble across it.
Is that right? Like, so here's the question. Suppose you're such a civilization. So you're like a Kardashev type 4 civilization. You have enormous energy at your disposal. And you have some sort of choice to broadcast to a narrow spectrum to a narrow cone of the sky at a higher power versus a higher fraction of the sky at a lower power. Why is one better than the other? What is the argument?
Well, I don't think it's a question of power. You might.
I think power it has to be related to it, right? I mean,
well, if you had the power resources of a Kardashev type 3 civilization, you could, if you wanted to, you could broadcast as brightly as a quasar, and you could be seen from the opposite side of the universe.
From all directions?
And that's,
yeah, but at the same time, any civilization that had that kind of technological advancement would have already found a way to search to see us.
No, that's not them seeing us. It's us seeing them. That's the issue.
I'm worried about
what I'm saying to you is that they would point their transmitter,
but they would know we're here.
The most likely planet.
But I'm wondering about this exact issue of the directionality. Like, in the trade-off between power and focus, what is the energy balance of that equation?
You know, the Benfords have thought about that a lot. And it does depend on the economics of energy for a given civilization. Now, there don't seem to be any Kardashev 3 civilizations nearby. Perhaps there are.
But let us stipulate that. Let's say we're looking for a civilization for why not?
And by the way, the Kardashev structure is just one mental model that you can apply. There's a lot of other more sophisticated ways of looking at it, but if you had the capability of harnessing a lot of energy, you could set. You
want to build a big radio station, and your objective is to broadcast to maximize the likelihood of being.
Well, what I would do is if I cared about my own galaxy, is I would send out along the plane of the galaxy a plane concentrated wave, and that should be detectable by a lot of civilizations. And there's a lot of other strategies. Seth Shostak did a good talk. You're saying
you think that there's a heuristic argument that you should aim for relatively low energy and high. I don't know what the word is. Like,
well, you wouldn't waste your time on things out of the plane of the galaxy.
Sure, but like within the plane of the ecliptic, like.
Well, the galaxy, not the ecliptic, but
yeah, right, the galaxy. Maximize the directionality, but don't worry about trying to economize on power because you gain more by spreading out in more directions than you lose by.
Well, but I mean, one thing the Benfords thought about was that, you know, the realistically, energy is going to cost something in any civilization, and economically, the MEDI budget for a given civilization may be quite low. So they may not have just any amount of energy they want to spend. And the problem is, and they send this wave out through the galaxy, right? It propagates out at the speed of light. At any given time, when it reaches that, that spherical radius or that disk radius, are there going to be civilizations alive there then, or are they going to be alive 1,000 years from then, or are they already dead? So you want to send it out over a period of time as well. Or you could do a targeted METI, which is where you've identified particularly promising solar systems and you blast energy at them. But the problem is that could be millions of solar systems.
Well, it depends on how narrow you consider for in your interpretation of pure life and a pure planet. You know, there we now know that almost all stars have planets. But if you're going to narrow it down to an Earth-like planet around an Earth-like star, you actually get to a reasonable number.
But a reasonable number is still a lot.
Still, the point is that any civilization who's capable of doing what you're talking about doing is also far more capable of identifying the viable, possible livable planets in the solar system.
We're practically on the verge of that.
They will be able to focus their transmission to those places.
Yeah, I think we're only a couple of generations before we start being able to do that ourselves. We're already have projects on the drawing board that would take us to that point. And
so once we can get exoplanet atmosphere signatures, we can go a long way toward identifying planets that potentially have a good potential of having life. And if you narrow that down to Earth-like planets around Earth-like stars that have what seems to be a biosphere from a distance, you've got a manageable number of planets within the galaxy and if you're only considering ones on our side of the galaxy, you've got an even more manageable number.
Yeah, well, I mean, close to you is a small number. As you start spreading out the galaxy, it goes to hundreds of thousands to millions and billions. And
not according. Alan Hale spoke at the Starship Congress, and he was breaking down the number of traditionally habitable exoplanets, by which I mean I'm not including subsurface oceans under iced up moons out of past the frost line. But he said, well, yeah, if you consider Earth-like planets in the habitable zone, there's millions of those. But once you narrow them down to things that when we say Earth-like, that could be in popular literature, that can mean a super Earth that is 5 times the size, a miniature Neptune, or it can, if you narrow it down to something much more Earth-like, you're looking for an Earth twin, you get down to a fairly small number, and it's not in the hundreds of thousands.
Yeah, once you're able to identify atmospheric chemicals and things like that, and identify what is actually a living planet, so to speak, like we are, the numbers go down. And to a quick note, I personally think that they're ignoring K-type stars.
No, they're not ignoring those. There's a lot of planets of the thing is, most of the planets we've identified so far, the vast majority have been through transit, and the transit probability at Earth-like planet around a sun-like star is very, very low. So you have to multiply by that, the inverse of that probability.
There's lots of face on solar systems that are probably we're obviously at this time at least we're missing. Because,
we'll know in about 15 years, if I live that long, Tess and Plato will have identified a lot of nearby transiting. Tess and Plato. Tess is launching next year. Plato will launch
transiting telescope, though.
Yeah, it's a cluster of telescopes. Plato will launch a few years later. It'll also look at sun-like stars near the Earth. We should have a very good census. Right now, it's not that great because
anyway, like you said earlier, we're only 2 or 3 generations away from having a really good knowledge of planets in our galaxy. A civilization only 100 years in advance of ours would have a pretty thorough knowledge of planets with biospheres in its home galaxy.
And if we could communicate with another civilization, it's overwhelmingly probable that it's actually not hundreds of years in advance, but thousands.
But don't forget about the obvious possibility. This is why I have a problem with the Fermi paradox. The possibility that a lot of let's just assume for the moment, just for the sake of brain thought experiment, let's just assume that every star around us within a few parsecs has livable planets. But we may be the most advanced one within our little group. So we may be waiting for them. Then, of course, there are those that are going to be more advanced than us.
The Fermi paradox doesn't say that, but
I know that it doesn't say that.
It's a bigger scale than that. But
yes, I know that. I'm trying to shorten it so that I can get it a word in edgewise. But the point is that the Fermi paradox talks about why haven't they heard us, or why haven't we heard them?
No, it's not. No,
maybe they're.
That's
long
not
gone.
what the Fermi paradox
maybe
says.
They died off 1,000 years ago.
The Fermi paradox says, why haven't they colonized us? That's the question.
We're thinking like humans. I mean, we're thinking like the apes that we are because that's what we would do.
No, it's just a question. That's all.
Well, it's a question that has multiple layers of presuppositions, and peeling away the layers of that onion has become
exactly
a very complicated.
Well,
that doesn't.
That's its whole utility.
That's
all.
Well, it's these presuppositions that I have a problem with.
But the point is, we learn something by taking away the layers of that onion. With each presupposition we take away, we learn something about the way we think about the world. And that's not wrong. It's just a particularly human way, filled with anthropic biases. But it is one way, the only way we know of in thinking about the world.
Yeah, we can't think about things that we haven't already.
We can't think about.
Yeah. Well, David Hume said it best, and I think it was something like, the mind can't deal with things it hasn't either mentally or physically been already attached to. I can't remember the exact words, but
did you say mind cat?
230 years ago, David Hume pretty much nailed it. So,
did you say mind cat?
Mind cat? No.
What did you say? Oh, I was going to say Cordwainer Smith's Game of Rat and Dragon was about pinlighting, and the partners were cats. But I didn't get to that part of the story yet. There was a hint.
Oh, that. Yeah. Shall we wrap up now, gentlemen? But I don't want to get Mike Bohler's final comments.
I got nothing.
Okay, that's your final comment. All right.
I got nothing. It started going way over my head here. With
Mike, tell us what's going on with Skeptics Guide to Conspiracy. What's your next frontier?
I'm trying to do a show on dirty electricity.
Dirty electricity? Well, there he is. We wonder why you left.
I can't seem to. I'm in like this major block. I've got the show recorded, but I'm editing it, and I'm like, this sucks. I'm not doing this right. So no, I want to. There's a lot of pseudoscience about electricity, things like magnetic fields causing leukemia and stuff like that. So I'm trying to put a show together that does a little bit of justice, and it's not coming together. But with the recent, what was I gonna? There was just with the eclipse coming up. I see a couple conspiracies popping up, so that may be an easier one for me to tackle.
Yeah, because
it's mostly about Nibiru is supposed to crash into the Earth and stuff like that.
Nibiru's coming. Yeah, that's the ticket.
Yeah, so I thought I understand the Nibiru question, or Planet X, or the all this stuff.
Zechariah Sitchin. He's the guru.
Yes.
He died a few years ago, but he's this guru of all this stuff. Yeah.
So I'm gonna do a show about that. I could do that pretty quick, get it out.
Yeah.
Keep my listeners happy.
That would be good. I would listen to that.
I'm definitely gonna do that. I'm trying also. I got to do a GMO show.
I'm sorry, Mike, could you plug your links to your blogs or whatever that is that you do, your podcasts, somewhere in the show notes or somewhere? Because I don't think
Skeptics Guide to Conspiracy. We've had the links in there before.
MikeBohler.com. That'll get you.
Okay.
Yeah.
And you spell Bohler B-O-8?
H-L-E-R.
Okay. I'm sorry.
Yeah. It's like every other podcast. You wish it would come out more often, but
Oh man, if it wasn't, you know what, when I was in Detroit, I had all this time on my hands, so I could whip out shows like crazy. I get back home, I'm back in my home base between work, trying to keep this house fixed. It's like, okay, I really have to force myself, and I a lot of times I get sidetracked. I was researching. Well, I think I'm trying to remember why I got onto the subject, but it's about eugenics. I think a book, something about or a story came out, and I'm like, oh, I didn't know about that part. It had to do with Virginia. Virginia, I guess maybe I think they finally apologized for their eugenics program, where they were sterilizing the feeble-minded.
they missed me.
Actually,
unfortunately.
I think California still has laws on the books that they could sterilize mental patients. Though I think maybe that was it.
They have lines around the block.
But
should.
So I got on that tangent. I had just read this book about Buck v. Bell decision that actually legalized sterilization of mental patients, feeble-minded. It's also like a subtext to like Alex Jones's little world he's in. So I wanted to chase that down. So, but I'm definitely going to do this eclipse, because I'm all prepared for it. I'm ready. I got one more filter that has to show up, but and then I'll have everything. But I got my contingency plans ready. If it rains or gets cloudy or whatever, I got a plan for that. So it's.
I don't have any contingency plans, but I am planning a party.
No, we'll get to you in a moment, Patrick. All right.
I'll do something.
I'm moving from left to right on my screen here. Okay. Nick Nielsen, what's coming up with you?
I can't think of anything that's coming up.
Oh, okay. How about you, Patrick?
Oh, okay. Before I go into the lack of contingency plans, I just want to make sure, from what I gather from this entire podcast, nobody has had a problem with any echoes from my microphone or anything like that, right? I sound great?
Yeah, we talk about technical issues off the air.
Okay, I just want to make sure because I want to be able to keep this on. Anyway, I am planning a solar eclipse party, and no contingency plans for a rainy day or cloudy day, except that I may be watching it on a computer over somebody else's broadcast. But I intend to project the sun, like I did in some of my videos. I can get an image as big as 18 inches in diameter. I'm not too worried about burning out my eyepiece, but although it's going to be a long, projection, I'm just going to wing it. But I won't be cooking anything. It won't be an actual barbecue unless one of the neighbors that join me does the cooking, because I have to make sure that any children attending don't try to look through the eyepiece. I also plan on getting some of the solar eclipse glasses from the library. I was told that I can go get some from the librarians there. So that's essentially my plans for 2017 American eclipse.
Sam's empty chair. What's up with you? We can talk to the empty. We'll have the debate with the empty chair. Sam?
So I've got my cameras. Yeah. Well, I was just going to say, to fill in the blank, I'm going to have my cameras on my telescopes, because I'm hoping to do some.
Uh-oh.
Anyway, I don't know if I'm going to do that or not. Put it up on a Hangout or something like that. But
I don't have any ability to bring the broadcast outside. There he is now. But I'm going to take photographs and put it on a video.
Okay, Sam, you get the almost last word. Sam,
Oh, sorry, I just came back.
you almost get the
What's
almost.
up?
You get the almost last. You get the penultimate word.
Goodbye to everybody. It's been a pleasure.
Ah, well, that's short and sweet. Okay. Hi, and this is your host, Paul Carr. By the way, I want to thank everybody who hosted while I was not hosting. I believe, let me see if I get this right. That'd be Sam, include Sam and Mateusz and Matthias and Adam Smith and David Gregg, and gave me some relief in a difficult point where I really wasn't prepared to organize podcasts. And I still would appreciate it whenever anybody wants to pick up that gig and run with it. It's good that we have multiple hosts, and I hope to continue with that for a long time. If you want to be on the podcast as a panelist, replacing one of these people, or augmenting them, that's easy to do. Just go to unseenpodcast.com. We have all kinds of information there about how you can do that, and we'll set you up. You can just email me at unseenpodcast@gmail.com, and I'll tell you exactly what you need to do to get on a panel. It's really not that hard, as should be evidence from what you've seen tonight. And and by all means, if you've been on a panel once or twice and you would like to be a host, that is also possible. Really, you don't need to have any technical savvy.
I'll vouch for it. It's not as hard as it sounds.
Yeah, I mean, I will not require any engineering skill from you. Just follow a procedure and it'll work.
No, I mean, Paul does incredible remixing behind the scenes. Like, he'll turn the feed into a magical, amazing, perfect paragon of unquestionable auditory bliss.
Yeah, all that is completely accurate.
As the host, it's not your responsibility, so it's easy.
So anyway, folks, if you're interested, by all means, please check us out and participate. This is an open participation podcast, which that's really why we have it. It's an experiment in letting anyone who wants to be on a panel to discuss interesting topics be on that panel, talk about it on air, and go on the permanent record. You have to be at least as good looking as these guys, but
that's a low bar.
That's a low bar.
You don't deny it.
Thanks.
Well, obviously, I don't talk about you, Patrick. We're talking about. Now, as we go out tonight, I want to do something a little different. The panel won't hear this, but I will add a promo for a podcast that I like that you will hear. It's a very short promo. Please feel free to enjoy it. The podcast is called Oh No, Ross and Carrie. And I recommend you listen to their podcast and admire their bravery and chutzpah, the stuff they do. And then they make a podcast out of it. So we'll be back in 2 weeks with the real episode on the 25th of August. And so this is now the official end of the summer hiatus. And we will see you. We have lots of stuff planned for the fall, including we're going to have Jake Robbins from the We Martians podcast on in October. And also in October, we plan to do something spooky, scary, weird, and quite skeptical. And we have all kinds of other stuff going on. We might get Ben Tippett back in the fall sometime. And by the way, Ben Tippett's done some work on time travel. So enjoy. I hope you'll be around and enjoy that. And we'll see you then. So this has been episode 76 of the Unseen Podcast. Stick around to check out the Ross and Carrie promo and the outro music, and we'll see you in 2 weeks. Good night.
This is Carrie Poppy.
I'm Ross Blotcher.
Oh, hey, Ross.
Hey, we're from a podcast called
Oh No, Ross and Carrie.
We find out what happens when you show up and ask questions.
We've hung out with the Kabbalists.
The Mormons.
We've gone and gotten ear candles.
Gone to the Sikhs.
We show up so you don't have to.
So find out where we're going next.
We'll even have special episodes where we have famous guests like Brian Dalton from Mr. Deity.
You heard that awesome theme music? He wrote that.
You should come visit us at onopodcast.com or
facebook.com/onrack.
What the hell's OnRack, Ross?
ONRAC.
Oh no, Ross and Carrie.
That's our show.
That's so smart. Come join us.
Woo!